Welcome to my Commodore 64 Games Memories. This is where I look at old games and some of the technical details behind them. Let's get into it. Today we have Quedex, published in 1987 by Thalamus. The programming and graphics and games design was by Stavros Fazolas, and I hope I've got your name correct there, Stavros. The music and sound effects was by Matt Gray. Loading sequence by Paul Doherty and Graham Hunter. The cover art and layout was by Oliver Frey. So this game I bought originally on disc. I was 14 at the time, I must have been. So the strange thing about the original version of this disc was that I actually had some trouble loading it. I had an Oceanic 1541 Mark II clone, and I don't think the disk protection actually played very well with that drive. And I noticed that when I try and run this G64 disk image in the emulator, sometimes the emulator doesn't boot the disk either. It goes through and it loops through memory, clearing memory, and then resets. Yes, it's done it again. It's cleared most of the memory, and then it's reset the C64. However, sometimes the same emulator with the same settings will actually run. This protection file, if you try and load it with 8.1, then it displays this message: "Hello hacker, hope you have fun with this disk. I'd like to point out that what you are doing is highly illegal, so go away," or something. But it loads into the start of zero page, and then loading into the start of zero page then screws around with the loading routines, the kernel loading routines of course, and it keeps on wiping through memory, which isn't really that friendly. But you see, this time when I loaded the game, it gets to this boot menu, so it does eventually work in the emulator, but only just sometimes, which I find is a bit odd. This loading menu is actually just really a simple basic program. Now, I was really surprised when I saw this little kind of like wiggly worm bouncing, smiling, grinning face type thing as a bonus item. We can see that it's got some sprites in there. Some of the sprites say Willy, which is funny if you're 14 years old and you find this sitting around in the middle of memory, for obvious reasons. And again, the disk has refused to boot. It does seem to be a little bit temperamental. This question mark file does this kind of like load thing, and then it gets eventually to the disk boot menu again. The other thing that was on this disk is actually the Hunter's Moon demo. I think I, to be honest, played the Hunter's Moon demo more than the game Quedex. So if you know this release, Hunter's Moon is actually a self-playing demo. You get to that screen and it says press space, and then it flies around. You see I'm moving the mouse around, it's being controlled by the computer. But I realised that if it was a self-playing demo, that it would have somewhere the recorded joystick moves. Now, back in the old day, I didn't have this, obviously the memory view that we were looking at there, but if we have a look in the memory view, we could see it was sequentially reading through memory to actually read the joystick inputs. Now, back in the old day, I actually wrote a little basic program to search through the whole of memory and look for memory with consecutive memory bytes that were within a certain range. I thought that maybe it was only storing 5 bits per byte for joystick inputs, because you've got up, down, left and right, and then the fire button, that's 5 bits. I looked for a memory range where it had consecutive bytes that were less than or equal to 5 bits in size. And eventually I found out that the game, the demo, the self-playing demo, was actually reading through this memory area at C000 to C0FF, and it was reading joystick bits. but it was also reading kind of like a timer value for each joystick direction and the fire button as well. So it was kind of like a compressed joystick bit, and then the number of frames that it would hold the joystick in that direction. So this was useful for me because I found out very quickly that I could change the code to just read the joystick and store it into that memory location 284E, which is where it's reading from the recorded joystick bits and then storing the resultant joystick bits into 284E. So all we need to do is just change the start of this routine, which reads the compressed self-playing data, to make it read the joystick. And now you can see that from the Vice emulator window, I'm moving the joystick with my keyboard, but I'm now controlling what should have been the self-playing demo. So now I can actually fly around inside the Hunter's Moon demo. So actually I played this demo a lot because it was something that hardly anybody else had at the time, because this was a demo that was released before the game was actually finished. So I could actually play around with this, and I could play around and experiment with altering the levels in memory, because the level data was loaded in as a file on the disk. So I had actually great fun just with the Hunter's Moon demo, just playing this one quite often. I remember searching through the memory and seeing if there was any sound effects or music code. I don't think I found any sound effects or music code at the time, so it was a silent but playable version of at least a few levels on Hunter's Moon. So anyway, let's get back to the main point of this video, which was actually to look at Quedex. So the next item in this boot menu is the Quedex loader, option B. So we can see that it's updating for the text, this character by character, scrolling on if you like, or reveal rather, with a little sprite ball over the top of it. As you would normally expect, the animating sprite spark in the middle is actually just a few frames of animated sprite. We don't have anything else in memory really. There aren't any hidden messages or anything else like that. There's a whole bunch of text which appears in that reveal down at the bottom of the bitmap screen, but it doesn't display anything in the borders or anything like that. I assume that at some stage it might have been an intention to have that as a loading screen on the tape version, but I don't recall that the tape version had much animation. Maybe it did. No, actually it probably didn't. I think it... I remember the tape version actually had the Quedex loader demo after the game on the tape. So now loading the game. We can see that the game load goes through several passes loading data from disk. Once the protection check is done, actually it seems to be using a fairly standard normal kernel load for the data. I do notice actually that we've got these random green sparkles occurring during the kernel load, and if we look at the CPU history, it's doing this indirected load with A4, X, and that's in the middle of the load routine, kernel load routine at F4, F9 look, where it's doing a JSR to FFE1, and it's jumping through that vector at 328. That vector at 328 is going to F6 E1, which is not entirely correct. So something has altered the vector at 328 You see, in the kernel disassembly, F6E1 actually doesn't really appear, so it's not a standard part of the kernel disassembly that it's jumping into. It's actually jumping into, through that vector, into the middle of one of those instructions, which is inside the middle of the load X. A6X A1 is actually loading. It's actually jumping to A1, so it's interpreting the instruction. It's interpreting the 0-page address as an instruction in its own right, which is, in this case, load accumulator with A4, X, indirected. So that explains why we're getting those weird green sparkles through the memory view, is that the vector has been updated to cause this. I've seen something once or twice in other loaders, to be honest, but the intent behind this is a bit weird. It causes the routine to load from a indirected address with whatever's in A4 and A5 and whatever is in X, but it seems to be quite difficult to actually control. Now this vector should be pointing to the kernel stop routine by default, you see, but by changing its entry point, then you're altering the way that the kernel routine tests for the stop key. In other words, it doesn't test for the stop key. So this indirected read is reading through lots of different memory locations. It's kind of a bit lucky that the indirected read is not accidentally reading one of the timer registers or the interrupt acknowledgement register, for example, or the interrupt control register, which would have some unintended side effects, to be honest. They're not random reads because they don't change all the time, but they are a strange pattern of reads. Let's just put it like that. Don't know why it would make it do that. Maybe it was a mistake. Maybe it was some attempt to fool certain hacking cartridges. Maybe certain hacking cartridges were looking for a trigger of reading various different locations in memory, and this would try and obfuscate that from the hacking cartridge point of view. Who knows? So we have this rather lovely title screen, which goes through this nice rolling demo effect. You have a nice fade out and fade in, and it goes through a little self-playing version of the level. We can see in the memory view where we've got these green rectangles. It seems to be using that as a virtual screen playfield, if you like, for the level as it's scrolling around. We can surmise from this that because this memory view is 256 bytes wide, a pixel per byte at this resolution, that the map is probably, because there are two green rectangles being read side by side, that it's probably at least 128 bytes wide, or characters wide, and the game is scrolling around there. What we can do actually is that we can dump a snapshot, and we can try and then also try and save just the whole of RAM at this point, and then maybe we can have a look at it in the character editor. In the disassembly there we can actually see a whole bunch of semi-unrolled speed code, the unrolled loop, the semi-unrolled loop, where it does a whole bunch of copies, loading from around about 9.7 and then storing at the screen at C4, C5, C6, C7. Loading this into CharPad, we can very quickly see where the character set is. That looks kind of like level data, doesn't it? But it is not at quite the right width. And there we go, now we have the correct width. And we look at this area in memory, we can see what it looks like, a partial or part of the game map. So let's go back and have a look at the memory layer in the game for the graphics. We have this one single buffered screen here at C400. As you would normally expect, it's scrolling around in terms of the characters. But if we have a look at the memory debug view, we can see that this bright yellow band here near the bottom part of memory indicates that the screen is being rendered all the time. If I paint over it with different characters, then the characters very quickly get replaced, so it seems to be painting over the screen very often. It's doing that because there's some character animations there, but you can see that the right hand side of the screen, where the score panel is not being updated or not being refreshed, and that is expected because we have this another game with a vertical split rather than a horizontal split. But you can see that the sprites, the score panel is basically composed of many sprites, and we have sprite 0, which is the highest priority sprite, using C040, which is filled with pixel color, so it's all filled with black because the sprite is set to black. But if we set the sprite now so that it has alternating vertical pixel lines of pixel and then transparent, or if we clear it completely, then it's completely transparent, we can see where the characters underneath are actually still displaying because the sprite has been effectively made transparent. This means now that we can see the hidden split between the score panel and the game status update and the game playfield, basically. So now we've painted the what should have been just black characters with visible characters, then the hidden effect of the vertical screen split is basically very obvious to see now. There isn't really a vertical screen split, of course, because it's not really technically possible to do, because the CPU doesn't have that fine level of control over the VIC chip, especially during bad lines. But it's just accomplished by using sprites, like all of the other games that have this kind of like vertical screen split. I'm not very good at this game, as you can see. It's interesting to note that that plain completed message didn't actually appear in the screen itself, in the text, in the character screen. Oh, there we go, that was the sequence. Okay. But the surprising thing about this game is that unlike the other vertical split games like Operation Wolf, for example, which used counter-scrolling character cells, this game just uses a whole great big bunch of sprites in the right hand side to show the score panel. The colorization for the sprites, the nice green fade out, the orangey, browny, pinky fading text is probably mostly accomplished by changing the multicolor registers, but you see the ball stays in the middle of the screen. So the ball can use all of these grey dithering patterns and stuff like that with no problem. Looking at the sprite data, it seems to be a combination of high-res and multicolor sprites as well. There seems to be at least 2 sprites being stacked for the ball and maybe another sprite being stacked for the shadow. We can look at the sprites in more detail in the C64 debug GUI. But what I liked about this game was that it has this title screen attract mode, giving a demonstration about how you play the game. Anyway, so going now to C64 debug GUI. Here we go. we can see that the 1541 emulation does the same thing as ICU64, is that when it's trying to load the directory, it just enters this seemingly never-ending loop of trying to read something. So if you break into the load, then that's the only way, seemingly, of escaping it. Don't try and load the directory because it won't work. I wonder how many people returned the disk because they thought that the disk was bad because they weren't able to load the directory. Seems to be a little bit of a daft design decision, to be honest. It encourages the user to think the disk is broken, and if you have any technical ability at all, you will still be able to read the disk directory anyway. So there's no real point in making the disk directory unreadable in a commercial release like this. If you want to hide it all, then just alter the directory so it only has the one file, which is your first loader file, and then remove all of the other directory entries, and then have a loader routine which specifically starts reading in chains of blocks on the disk, as you would normally do with other protection schemes, right? We can see that the directory has this little hack which makes it show the green title of the disk, which is Quedex. Anyway, I quickly figured out when I got this that you could load the Andy program and it would circumvent all of the protection checks on the disk. So the disk protection really wasn't much good. Anyway, this Andy program is basically the disk menu that we can see there in memory. If we run it, we can very quickly get to that disk menu because it is the disk menu program. We can now see the kernel load going through the game load. In this memory view, we can see the kernel routine being accessed and the code being executed in the kernel during this load, so there doesn't seem to be anything special about this loader at all. So we get to the title screen, we can see immediately that we have this large expanded sprite grid over the characters of the title screen. We can see that we have vertically expanded sprites down the middle, which obscures the scrolling area for the game. We can see what looks like two sprites at least for the ball, and then one sprite for the shadow. So this large expanded sprite grid that we can see here actually accomplishes the nice vertical wipe, fade out and fade in effect, the transition between the different parts of the title screen. We saw a similar thing in Turrican, right? Or was it Turrican 2, where a sprite grid was used. I think it was Turrican. I'd have to go back and check. But a large sprite grid was used in other games to accomplish this very similar effect. But once we get into the game, we can see exactly the sprites that are used for the score panel update. We can see exactly, actually, surprisingly, that the text scrolling around with the game for how many bonus seconds or points that you got was scrolling around. Those are sprites as well. But as we move the targeting cursor up and down the screen, we can see all of the sprite multiplexing that's going on. There's 1, 2, 3, 4, 5, 6, 7, 8 sprites horizontally, up to 8 sprites horizontally, as you would normally expect. The part of the screen in the middle where the ball is, of course, the sprites being used there are being used for the ball, so we don't have any score panel right in the middle of the screen because we want the sprites for the ball. And during the game, of course, there are extra sprites being used for the explosion effects. The text which comes up there is actually sprites as well. So we have a raster bar color effect for the text as well going down the screen. behind the sheet of sprites, or the grid of sprites. So there is quite a lot of sprite multiplexing going on in this game. And because we've got quite a lot of sprites being used for the score, then the sprites that's being used for the main display is actually quite restricted because of the horizontal sprite limitations that you have for each horizontal line, which is up to 8 sprites. So you can see actually there's quite a lot of sprite multiplexing going on here. The use teleporters message, for example, is a load of sprites. When I look at this game and how it does the effect, the immediate expression that springs to mind is basically by brute force. It's using sprites very effectively, but basically brute forcing the vertical playfield split, and it's using that for the score panel. Now this fade in and fade out routine here, I've paused the title screen during a fade in and fade out. So there's this transit, we're in the middle of the fade transition, if you like. So the sprite that was being displayed was using sprite data at C000. So we scroll through and I place the cursor at the correct memory address. There we go. And now the sprite data has synced up. We can see that the sprite here is 3 horizontal bands, which correspond to the 3 horizontal bands that we can see being repeated in these horizontally and vertically expanded sprites, and a 4 by 1, 2, 3, 4, 5. So a 4 by 5 X and Y horizontally and vertically expanded grid of sprites is enough to cover the entire play field, while also leaving a sprite vertically expanded, which is a black sprite covering the vertical split on the screen, and then leaving 3 sprites available for the score panel, and or those 3 sprites available for the ball at that particular horizontal position on the screen. So yes, a lot of sprites are used in this game, but it differs to, say for example, Operation Wolf. Because Operation Wolf was only doing this horizontal scroll, its vertical split can use counter scrolling characters and updating the characters that way to use characters for most of the score panel update. Not all of it, but most of it. And so Operation Wolf is less limited. It can use more sprites for its game display, whereas Quedex doesn't need it. So let's have a quick look at the protection. Now, this site, which is C64preservation.com, says that there is a signature check on track 41. And this site, which is the preservation64.de site, also, well, it says it's by Prism Leisure Protection. And it also says that there is data duplication on track 41, and that the disk title in the directory is modified to show in a green colour. But as we saw, we can just circumvent the disk protection just by loading the Andy file, which is the game menu. Now, loading the directory into the default basic area, it eventually gets to track 35 and does this flashing error report, and you can see that the load has stalled in the graphics map there, and the memory view is not showing any further writes to memory at all. It's just filled it up to that extent, and I pressed the stop key. When we list the directory, we do see that green disk title, which was mentioned in the page for Prism Leisure protection. We can see the other games that use it as well. I wonder if they all use a very similar broken directory layout. When I say broken, I mean the directory chain which goes to track 35 and then produces that visible disk error or that disk stall. Using my updated version of C1541 with the recover command, it did recover a whole bunch of files that were not, or file chains from blocks that weren't in the directory, but to be honest, they all seem to be duplicates of, well, this is actually the directory entry itself, but they don't seem to contain anything interesting as such. The recover command stops trying to save data when it reaches an invalid track or sector. So this is why the file has a set length. On the Commodore 64, usually if we try and load the directory 8,1, it will read it into screen memory as opposed to loading it into basic memory, and we can see in the emulator, even in the more recent emulator, the load doesn't fail per se. The load just goes into this state of flashing the error light on the disk at track 35. So why does it do this? Why was the disk updated to break the directory? Well, if we have a look at the disk image and we have a look at the chain, we can see where the chain breaks. Eventually a chain tries to get to track 75, which is obviously out of bounds, and it cannot read the GCR track because there is no track 75 in the disk image or on the disk, and then it fails. It fails in the C1541 utility because it doesn't want to, continuously show a disk error in the C64 emulator. It's not emulating a C64, to be honest. It's looking at the disk structure. So if we follow the chain manually using the bpeak command, we can see eventually the chain gets to trying to read track and sector 23 in hex, which is in decimal 32 plus 3, which is 35, right? Track 35 sector 0, and then track 35 sector 0, when we read it, then points to track 75. So 23 in hex and 0, there we go, 4B and 1. 4B is hex, and we want the decimal value, which is going to be 75. So the 1541 directory read, at the very least, which is basically akin to a file load from the C64's point of view, the drive ROM code doesn't seem to know how to handle a request to go and read or continue reading the directory information from track 75, and it gets into this weird state, which on the Commodore 64 side you can escape by by pressing the run stop key, and it stops the load, but the drive still is in this confused state. The other files on the disk directory are all kind of like laid out as you would normally expect. The files start at track 17 sector 0, then goes to track 17 sector 1, sector 2, sector 3, so on and so forth, because the first few files are actually relatively quite short. Then there's the standard auto starting or auto run boot file, for example. So I think we'll leave this video there. I just really wanted to have a look at the vertical screen split and go through some of the example or demos rather on the original disk image that I remembered from when I was back at 14 years old. seeing the bouncing, what was it called, the Willy Worm demo, immediately made a whole bunch of very old memories come flooding back, which reminded me that, you know, I had made the self-playing Hunter's Moon demo playable as well. So that's all been a very enjoyable, for me anyway, recollection, and I hope you've enjoyed this video as well. If you like these kind of technical deep dives into old Commodore 64 retro games, then please do consider liking or subscribing to this channel, and I hope to catch you around next time. Take care, have a great day or night, wherever you are.